All right, honors geometry. So this is the first of 6 videos. Again, I'll make a video per example, per task, so you know exactly what to do. So this project is due next Wednesday, January 13th. It's over what are called conic sections. So we talked about cross sections when we did volume. So this is sort of like what conic sections is referring to. Conic sections are examples of cross sections, except what you're doing is you're creating a cross section on this double napped cone, which are 2 cones that touch at the tips. So you can see that there are 4 major types of conic sections: a circle, an ellipse, a parabola, and a hyperbola. You are familiar with circles from this class and parabolas from Algebra 1. The ellipse and hyperbola will be new, and we'll talk about that later on in next videos. But again, you can see that when these 2D planes intersect these double napped cones in certain ways, you get these different cross sections that we call conic sections. And again, because they're made out of these cones. So the first one that we actually did in this class is a circle. So by definition, right, a circle is the collection of all points x, y that are equidistant from a fixed point, the center. And that distance is called the radius, r, right? So we can use the distance formula to find the equation of a circle, right? So we do this distance formula. We let x2, y2 be the center. We let x1, y. We let x2, y2 be the point xy. We let xy be the center hk. We square both sides, and that's how the radius gets squared. And there's your circle equation right down here. Okay, so that's going to be helpful in this first task. So the first task, part 1a, the definition of parabola. So we're going to look at the definition of a parabola from a very analytical geometry standpoint. So it says that the definition of parabola says a parabola is the set of all points x, y in a plane that are equidistant from a fixed line, which is called the directrix, and a fixed point called the focus, not on that line. Okay, now we are used to parabolas opening vertically and vertically, right, up and down. Now that is going to be your task. So in order to show you an example, I have to focus on the parabolas opening left or right horizontally. So I'm looking at this parabola opening up to the right. So the parabola is the green curve. I picked a point xy on that green curve, and I labeled 2 distances. First, the distance to the focus. So the focus is in line with the vertex. It's just p units to the right. So this distance between these 2 points is a distance called p. Okay? So there's the focus. That's the first distance we have to work with. The second distance is that point to what's called the directrix. The directrix is a line same distance away from the vertex as the focus is. So from this vertex to this line is also p. So you can see that the equation of the directrix is h minus p. It's the x coordinate of the vertex minus that distance p, because it's to the left of it, behind it. Okay. What we need to do is we need to solve this problem right here. d1 equals d2. Use the distance formula to find the distance 1 algebraically, then set it equal to distance 2, because by definition they're the same, and we are going to arrive at this equation. And again, this is the equation for a horizontally opening parabola, and it opens to the right. That's why there is a positive 4p. If this were to open to the left, it'd be a negative 4p. All right, so let's go ahead and derive that right now. Again, let's remind ourselves what the distance formula says. The distance formula says x2 minus not x squared, right? That's like what you guys do. What am I doing? So parentheses x2 minus x1 squared plus parentheses y2 minus y1 squared, all inside the square root. So we're going to do that for distance 1 and for distance 2. So I'll go ahead and write that on. Distance 1 is going to equal distance 2. So let's do distance 1, and I'll do it in red, right? Now we want y minus k squared. So I'm going to start with x and y when I do my subtractions. So parenthesis, let me scoot over. I think I need more room, right? It's a big one. Parentheses x minus, and now we have to subtract this binomial. So I'm going to open up another parenthesis, h plus p, close that parenthesis squared, plus y minus k, it's pretty simple, squared, and that's inside the square root. So that's your distance 1, and that's going to equal, and now we do our distance 2, and I'll do it in blue. Again, I want x minus h, so I'm going to start with the x and y. That'll be parenthesis x minus. Now your x coordinate over here is h minus p. So put that in parentheses because it's a binomial, h minus p squared, plus, and then it's y minus y, which you should recognize as something nice. Okay, so we're going to take this and we're going to try to derive that formula. So what I'm going to do here is I'm going to square both sides. When I square both sides, the square roots and the squared will cancel, so no more square root. On the right-hand side, y minus y, that's 0, and 0 squared is 0. That goes away. Now, it's very important. On this side, we want to keep this. We don't want to touch the y minus k squared, right? Because we want that. But we do want to mess with this, and we want to mess with this. So this is where your algebra skills come into play. So I'll start with the red one first, right? Let's distribute the negative sign, and let's write it twice. So when I distribute the negative sign, I get x minus h minus p, and I'm going to write it twice because it's squared. And now we're going to distribute this all out. And what it means is everything in the first parenthesis gets multiplied with everything in the second parenthesis. So x to x, x to minus h, x to minus p. So we're going to get, let's do it here, x squared minus xh minus xp. Then we'll do the minus h to all three things. So negative h times x is negative xh. Negative h times negative h is positive h squared. Negative h times negative p is positive, and I'll go hp. And now we do the minus p to all three things. Negative p times x is negative xp. Negative p times negative h is positive hp. Negative p times negative p is positive p squared. Hopefully you can see that. So now let's simplify this. There's only one x squared. There are two minus xh's. There are two minus xp's. There's an h squared. There's two hp's. And there's a p squared. And there we go. So that's what this left-hand side is going to be with this y minus k squared next to it. Okay. All right. So now let's change colors and do the blue side, right? So very similar. Let's distribute this negative sign. So now it's going to say x minus h plus p. Write it twice. Now again, let's distribute the x to all three parts. X times x is x squared. X times negative h is negative hx. X times p is positive xp. Then let's do the negative h to all three parts. Negative h times x is negative xh. Negative h times negative h is positive h squared. Negative h times positive p is negative hp. Again, be very careful. It's very easy to make a mistake. And then do the positive p to all three parts. P times x is positive xp. P times negative h is negative hp. And p times p is positive p squared. And now let's simplify that. So the x squared is all by itself. There are two minus xh's. There are two plus xp's. There's an h squared. There's two minus hp's. And there's a p squared. Okay, so now if I scroll down, I'm going to try to scroll down a little bit and see what I can do. Sorry about that. Okay, so now in red, my left-hand side is now x squared. Here, let me scoot over just to make sure I have enough room. Oof, it's long. It's algebra, right? It's fun. X squared minus 2xh minus 2xp plus h squared plus 2hp plus p squared